Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Dear students, this lecture is for grade 9, subject chemistry, chapter number 8, and this is my 30th lecture. And in this lecture, we will discuss the remaining topics of chapter number 8. And I am your lecturer, Mrs. Saira Jamal. The topic about which I'm going to talk is electronegative character. What is meant by electronegative character? The tendency of atom to gain electrons to form anions. Negatively charged ions are called anions. Is called electronegative character. Electronegative character is the reverse of electropositive character. Electropositivity is the tendency of an atom to lose electrons and to form cations, means positively charged ions. While electronegativity or electronegative character is the reverse of electropositive character, that is tendency of atom to gain electrons to form anion is called electronegative character. Non-metallic oxides are acidic in nature and they show the non-metals shows this electronegative character. Electronegative character general trend. A long period electronegative character increases while electronegative character decreases along the group. Along the group from top to bottom, electronegative character decreases while electropositive character increases. This is due to decrease in nuclear charge and increase in atomic size. While from left to right, electronegative character increases while electropositive character decreases. The reason is increased nuclear charge and decrease in atomic size, which binds the extra electron more tightly to the nucleus. Hence, electronegative character increases from left to right but decreases from top to bottom. You can see in this image electronegativity or electronegative character increases from left to right and it decreases from top to bottom. From bottom to top, definitely it increases. The electronegative character increases, but from top to bottom, electronegative character decreases. Example 8.1, in each of the following pairs of elements, identify which element is more non-metallic. Which element is more non-metallic? Number 1, nitrogen or oxygen. Number 2, fluorine or chlorine. Let us see in the periodic table nitrogen or oxygen. Nitrogen or oxygen is which one of the following is more non-metallic? So let us see the periodic table. You can see in the periodic table nitrogen is present in group number 7 and oxygen is present, nitrogen is present in group number 5 and oxygen is present in group number 6. We can also call it 15 and 16. So as I told you that electronegative character increases from left to right along the group. It means oxygen will be more non-metallic than nitrogen, or electronegative character of oxygen will be greater than nitrogen. So oxygen is more non-metallic than nitrogen. Fluorine or chlorine, as fluorine and chlorine belongs to the same group. Fluorine and chlorine both belongs to the same group. And as I told you that non-metallic character or electronegative character decreases from top to bottom. So it means that the non-metallic character of fluorine will be greater than chlorine. Fluorine is more non-metallic than fluorine. Then self-assessment exercise 8.3, question number 1. In each of the following pairs, identify which element is less non-metallic. Less non-metallic, boron or carbon. Which one is more non-metallic? So boron is present in group number 3 and carbon in group number 4. It means that non-metallic character increases from left to right. So carbon will be more non-metallic and boron will be less non-metallic. So since boron and carbon lies in period number 2 and in period from left to right non-metallic character increases, therefore boron is less non-metallic than carbon. You can see here this is boron and carbon. Both are present in second period. This is period number 1, period number 2, and as we know that non-metallic character increases from left to right. So less non-metallic will be boron and carbon will be more non-metallic. Second one is carbon or sulfur. Carbon or sulfur, since carbon and sulfur, carbon is present in group number 4 and sulfur is present in group number 6 of the periodic table. So if it is a silicon, suppose carbon or silicon, so carbon or silicon, Si, they belong to same group of the periodic table. This is actually silicon, carbon or silicon. Carbon or silicon, they both belong to same group, group number 4. So what will happen, as carbon and silicon lies in group 4A and group 4, from top to bottom, I told you the non-metallic character decreases. So silicon is less non-metallic than carbon. Then chlorine and bromine, they also belong to the same group. And chlorine, bromine comes after chlorine, chlorine and bromine. So as the non-metallic character decreases from top to bottom, therefore we can say that the bromine is less non-metallic than chlorine. Bromine will be less non-metallic than chlorine. Then question number 2 is, using periodic table, rank each set of elements in order of increasing non-metallic character. So if you will arrange them on the basis of the non-metallic character, you can see that we have the first case. In first case we have nitrogen, fluorine, and the oxygen. So nitrogen is present in group number 5 and fluorine is present in group number 7 and oxygen is present in group number 6 of the periodic table. Since nitrogen, fluorine and oxygen lies in second period and in period from left to right, the non-metallic character increases. Therefore, we can say that fluorine is more non-metallic than oxygen and oxygen is more non-metallic than nitrogen. As I told you, this is fluorine is present in group number 7, oxygen in 6, and nitrogen in 5. So it's understood that when we move from left to right along the period, I told the non-metallic character increases. So the less non-metallic will be nitrogen and the more non-metallic is fluorine. In the second case, chlorine, bromine, and iodine, and I told you that the non-metallic character, as they belong to the same group, fluorine, bromine, and iodine. In group number 7, the first element is fluorine. Then we have fluorine. Then we have bromine. So fluorine, chlorine, bromine. And I told you that from top to bottom, what happened to the non-metallic character? Non-metallic character from top to bottom decreases. It decreases, non-metallic character decreases from top to bottom. And it increases from left to right. So the most non-metallic character the element which have more non-metallic character, that will be fluorine, then chlorine, then bromine, and after bromine is iodine. Iodine will be least non-metallic in nature. So the arrangement will be that this must be fluorine and this must be iodine. So as I told you that iodine will be the least non-metallic, then bromine is more non-metallic than iodine, and chlorine is more metallic, non-metallic than bromine. So the order is chlorine is more non-metallic than bromine, and bromine is more non-metallic than iodine. This is their sequence. C1 is sin silicon. This is silicon, sulfur, and phosphorus. Silicon, sulfur, and phosphorus. So silicon is Si. Silicon, sulfur, and phosphorus. They are present. Silicon is present in group number 4, and phosphorus is present in group number 5, and sulfur is also present in group number 6. No, sorry, silicon is in group number 4, sulfur in 6, and phosphorus in 5. So since nitrogen, this is the C1, since silicon, sulfur, and phosphorus, they lies in the same period, that is in period number 3. So from left to right, I told the non-metallic character increases. Therefore, the group 6 1 sulfur will have more non-metallic character than group number 5 1 phosphorus, and the 5 1 have more non-metallic character than group number 4A of the periodic table. They have more non-metallic character. So these properties changes with the group number, or when we move from left to right, or top to bottom along the group. The next topic is about the comparison of reactivity of the halogens. What are halogens? The elements of group number 7A of the periodic table are called halogens, and this name is derived from Greek word halos. Halos meaning salt and gen meaning former. So halogens includes which element? Fluorine, chlorine, bromine, iodine, and astatine. All you can see that all these except astatine, which is a radioactive element, the rest of all the halogen, they exist in diatomic form. And the color of fluorine gas is fluorine is a gas, so it is pale yellow gas, and chlorine is green yellow gas. Bromine is liquid, so reddish brown liquid. Iodine is solid, bluish black solid. And astatine, I told you, is a radioactive element. It emits radiations. Halide formation. Halogens react with metals to form salts, and those salts are called halides. Like sodium metal react with chlorine to form sodium chloride, which is a salt, and those salts are called halides. In these reaction, metals are oxidized, so halogens acts as a reducing agent. Fluorine is the most reactive element known. Fluorine is less reactive, but it combined vigorously with many metals. Although it is less reactive, but with metal it reacts fastly. For example, a sodium metal, I told you, burn in chlorine gas to form sodium chloride. The reaction you can see, sodium when react with chlorine, or when we burn it in chlorine gas, it will give sodium chloride, which is a salt, and this is called halide. Sodium react with metal to form, so metal react with halogens to form halides. And as you know that in this case, if we see, or if we look at their oxidation state of elements, so you know that in elemental form, oxidation state of sodium is 0, chlorine is also 0, sodium become plus 1, and chlorine is -1. So you can see sodium undergoes oxidation because its oxidation state changes from 0 to +1. So it undergoes oxidation and will act as a reducing agent, while chlorine undergoes reduction because its oxidation state changes from 0 to -1. So as it undergoes reduction, then it will act as an oxidizing agent. So that's why they say that the halogen, they acts as an oxidizing agent because they reduced themselves, they reduce and will act as an oxidizing agent. Then we have bromine and iodine react with metal less vigorously. Fluorine is more or highly reactive than bromine and iodine are less reactive. The reactivity of halogen decreases down the group. That's the order of decreasing order or power of oxidizing power. Like as I told you that they reduce themselves and oxidizes the metals. So which halogen will oxidize the metal more easily or more vigorously? That is fluorine. It's because it is highly reactive, then fluorine, then bromine, and then iodine. So oxidizing power of fluorine is greatest, then fluorine, then bromine, and then the least oxidizing power is of iodine. Hydrogen halides, what are hydrogen halides? Reaction of halogens with hydrogen to form product or to form acids or hydrohalic acid are called the hydrogen halide. Those compounds are called hydrogen halides. So the hydrogen halide dissolve in water to form hydrohalic acid. Hydrohalic acid means if the reaction of hydrogen is with chlorine, it will form hydrochloric acid. With fluorine, hydrofluoric acid. So all these except hydrofluoric acid, other hydrohalic acid are strong acids. What are strong acids? Those substances which give proton in water or in aqueous solution are called acids. So hydrofluoric acid actually is not giving hydrogen ion easily. That's why it is a weak acid. But the rest of hydrochloric, hydrobromic, hydroiodic, they are strong acids. So the strongest acid is hydroiodic because it can give the proton very easily due to the large size of iodine. And then hydrobromic acid is stronger than hydrochloric, and hydrofluoric you can say is the weak acid, the weakest acid. Oxidizing power of halogen, I told you oxidizing power of halogen decreases down the group. So the strongest oxidizing agent is fluorine. So fluorine is the highest and that of iodine is the lowest. It has the lowest oxidizing power. So due to the relative strength as oxidizing agent, it is possible for a free halogen to oxidize the ion of halogen next to it in the group. This means fluorine can oxidize all the halide ions which are present under fluorine in group, but the groups or the elements which are present under fluorine, they cannot oxidizes the fluorine. So as I told you that we have the halogens, that is the top one is fluorine. Then after fluorine we have fluorine, then bromine, and iodine. So fluorine has the most strongest oxidizing power and the least one is with iodine. It means oxidizing power decreases when down the group. So fluorine has the strongest oxidizing agent. So in any compound, fluorine can replace chlorine, bromine and iodine, but those elements which are present down the fluorine, they cannot displace the fluorine from its compound. Fluorine can displace all. Fluorine can displace chlorine. Fluorine can displace bromine, and fluorine can also displace iodine from its compound due to its strongest oxidizing power. But the lowest elements like chlorine cannot displace fluorine. Same, bromine can not displace fluorine, or even it cannot displace fluorine. It means the lower animal cannot displace the upper element in from its compounds, but the upper element can displace the element which are present under them. So look at the first example. Can fluorine displace chlorine from this compound of potassium chloride? You can see with potassium chlorine is present at the reactant side, but at the product side fluorine is present with potassium. It means fluorine can displace fluorine from its compound and can convert it chlorine into its free form or in elemental form. And fluorine can displace bromine also and will give bromine liquid, and fluorine can displace iodine also from its compound to form iodine in free form. Similarly, chlorine can oxidize bromide ion and iodine can oxidize any and iodine can oxidize any halide ion. So chlorine is present above bromine and iodine. So chlorine can displace bromine and also iodine, but iodine and bromine they cannot displace chlorine because in the group they comes after bromine. Then we have an activity. This activity is actually to identify the salt. This is actually called salt analysis. And in salt analysis, if a salt is provided to you for practical purpose and they ask you to identify which salt is provided to you, so that type of practicals are called salt analysis, and this activity is actually important for practical point of view. The first activity is that we have to identify the radical or the salt. We know that each salt is composed of two radical, cations and anion. So the cations are called basic radicals and anions are called acidic radicals. We have to identify the salt. So for this purpose, we need the apparatus. We need test tubes, watch glasses, glass rods, and the chemical which we need: concentrated hydrochloric acid, cobalt nitride, sodium hydroxide, a platinum wire, and the salts provided to us are ammonium, calcium. The basic radical, actually the cation are ammonium, calcium, magnesium, barium, and zinc. And now we have to identify these basic radicals one by one. First of all, we have to do a test which is called flame test. For flame test, we will check the color of the flame produced by each salt. But first of all, we will prepare their paste. The paste of these salt with concentrated hydrochloric acid. Make a thick paste of each salt by putting few drops of concentrated hydrochloric acid in the solid salt and mix them, and take a little of the paste on a clean platinum wire and place it into the non-luminous flame of burner, and then we have to check the color of the flame. You can see here, this is the watch glass. In watch glass, first we will put the salt and then we will put a few drops of this concentrated HCl in it. We will mix them and we will make a paste of it. This is the platinum wire. We will take a little paste on this platinum wire and we'll hold it on the flame and we'll check the color of the flame. We have two types of flame. One is called non-luminous flame. Non-luminous flame you can see is the lighter flame, and the luminous flame is the strongest flame, which has more temperature than the non-luminous flame. We will hold the paste of the salt in this non-luminous flame, which has not too much heat, and we'll check the color of the flame. So you have to check the color of the flame carefully. This is actually the platinum wire, which is attached with the glass rod, and we will make a loop of it and we'll take a small quantity of the paste and we'll hold it on the fire. And now check the color of the flame. If the color of the flame will purple, it means the salt contains basic radical potassium. If it is greenish, bluish green, then copper. And if it is golden flame, then sodium. The orange, reddish orange is lithium. Brick red is for strontium, and apple green is for the barium. So these different color flame will help us in identification of the basic radical, at which type of basic radical is present in our salt. Shake, this is the second test now after flame test. The second test is called the cobalt nitrate test, or it is also called filter ash test. So cobalt nitrate test or in filter ash test, what we will do, we will take the cobalt nitrate solution and we will mix it with our salt, and then we will take a filter paper, we'll dip it in this cobalt nitrate solution which contains also the salt in it, and then we will burn that filter paper and we will check the color of the ash. So if the color of the ash will pink color, it indicates that magnesium salt are present. And if the ash color is green, it indicates the zinc salt. So you can see in this image, first we will take the cobalt nitrate solution and mix it with our salt, the given salt. We will dip this filter paper in the solution. We will take that filter paper and we will burn it. And then after burning, we will check the color of the ash. You can see the color of the ash is greenish color, which indicate that our salt contains basic radical zinc. Then the third test is take each salt in separate test tube and add some sodium hydroxide solution to it, and then we will heat it or boil it. The test tube in which pungent odor gas, pungent means irritating gas, a strong irritating smelly gas evolve. This test gas with a glass rod dip in HCl, and take a glass rod, dip it in HCl and hold upon the gas. If the gas give white fumes of ammonium chloride, so if white fumes appear, it means that it is giving ammonium chloride, because ammonia will react with HCl and will form ammonium chloride, and it has white fume. If white fumes will form, it means that ammonia is present, ammonium ion is present, react with HCl and will form white fumes of ammonium chloride. If no fumes will form, no white fumes will form, it means that the given salt does not contain any ammonium salt. So this is all about the activity, the first activity. Inshallah, the other activities and exercise we will do in our next lecture. Till then, take care. Allah.